Today we are going to discuss about the double linked list. In our previous video sessions, we have seen the single linked list. There we have seen the various operations performed on a single linked list, that is the insertion in a single linked list in a 3 ways and deletion in a single linked list using 3 different ways. Now we are going to discuss about the double linked list. This is the structure of the double linked list. If you observe this one, here also we are going to have the start pointer which will have the address of the first element, similar to the single linked list. Now, in a double linked list, every node is going to have the 3 elements, that is the left link, data and the right link. Whereas in a single linked list, we used to have only the left link and the data. But in a double linked list, we are going to have one more advantage, that is we are going to have the 2 addresses and the data point. What are the 2 addresses means? This is the left address, this is the right address, and in the middle we can have the data. This is the structure of a double linked list. And this double linked list is a 2-way list. Why we are going to say that it is a 2-way list means, in a single linked list, once if I move forward, like from the first element, if I move to the second element, I cannot come back. Whereas in a double linked list, I can move backward because of this left link. This left link is going to point to the previous one and the right link is going to point to the next address. And in the data, you can store the data. This is a double linked list node. That's why this is called as a 2-way linked list, in which all the nodes will have the 2 links. This helps in accessing both the successor node and the predecessor node. What is a successor node and what is a predecessor node means? The previous one will be treated as a predecessor node and the after this element will be treated as a successor node. So here, that particular node is going to point the both address. One is the predecessor address, the other one is going to point the successor address. And this is also used for the bidirectional traversing. It also provides bidirectional traversing, means I can move backward. After reading this data, if I want to move backward, again I can move backward. That is called as a bidirectional traversing. This is a general definition of a double linked list. So what we have to discuss first, we need to start our discussion with the start pointer, where it is going to have the address of the first element. And in this double linked list, every node is going to have the 3 elements, 3 parts. This node consists of the 3 parts. The first part is the left part, left link, data and the right link. Even this left link is also discussed as the next previous, and the right link will be treated as a next. Sometimes in our coding we used these terminologies, that is the previous terminology and the next terminology. Done. Now see, the left link points to the predecessor node. In this one, this is called as a left node, this is called as a right node. The left link is going to point to the predecessor node, the previous element, and the right link is going to point to the successor node. This is the right link, right? So it is going to have the address of the next element in this one. So this node is going to point to the predecessor element in the left link, and this is going to point to the address of the next element in the right link, that is the predecessor node and the successor node. While writing in the exam, you need to be very clear that which is the predecessor node and which is the successor node. The data field stores the required data. Here, this is the required data. I can store here in the data section. And where we are going to use means, in many of the applications, we require both the forward and the backward nature, like the telephone dictionary. There are many applications where we need to apply backward and the front. At that time, we are going to go with the double linked list. Yeah. And what are the operations we can perform on this double linked list means, similar to the single linked list, that is the insertion, deletion and the traversing. These are the basic operations we are going to perform on a double linked list. Yes, and one more important thing here we need to discuss is where we are going to have the null address in a double linked list. If you observe in a single linked list, only the last pointer, the next address is going to have the null address. But here in the double linked list, the first element left link and the last element right link is going to point to the null, which means that there we are not storing any address. How can I say that this is the first element? Means if the element left link is pointing to the null, which indicates that this is the first element in a double linked list. And when can I say that this is the last element in a double linked list? Means if the element right link is having the null address, then we are going to say that this is the last element in a double linked list. This is the general structure of a double linked list. So what we have discussed till now, in a double linked list, every node consists of the three parts, that is the left link, data part and the right part. Left link is going to point to the predecessor node and the right link is going to point to the successor node. And in a double linked list, the first link previous pointer is going to have the null address, and the last link, the last element, next address is going to be marked as a null address. This is the general definition of a double linked list. And how many operations we can perform on this double linked list means same. Creating a node, insertion, deletion and the traversing in a linked list. Yeah. And how we are going to create the node? Like we have seen in a single linked list, we have seen struct node, int data, struct node pointer next, right? Similarly, the same structure we are going to follow. Here we can give any name, like in the previous node we used to give only struct node, right? Here also you can say that struct node pointer left, int data, struct node pointer right. Like this you can directly define. If you are getting confused with the many formats means you can follow the previous one itself, that is the struct node pointer left, int data, struct node pointer right. After this you can close this one. This is a general structure of a node, like this, left, right and data. This is a node, and initially the start pointer must have the null address. Then we are going to say that this is an empty list, and this is also type def. Instead of giving the struct node, if I want to call this particular node means I can define like this, that is type definition. For this particular struct delinked list, we are going to call with the name node. So that's why node pointer start equal to null. Instead of saying that struct node pointer start equal to null, they are defining this struct delinked list as a node. They are saying that node pointer start equal to null, which means that the start pointer will be created with the value null, initially empty list. This is about the node creation. In the single linked list also we have seen the same structure like this only, but there we are going to have only one pointer, but here we are having the two pointers. Yeah. Now we are going to see creating a node for a double linked list. First we need to discuss about how we are going to create a node, how we are going to call that function, that is struct node. Already we have seen this, struct node pointer left, int data, struct node pointer right, and here the semicolon. This is the general syntax. No one should do the mistakes here. Yeah. After that, initially the start pointer is going to have the null value. With this one, what happened here? The node is created with the left link, data, right link, and start pointer is also created with the null value. Next, we are going to call a function getNode function. We are going to call a function getNode function. In that getNode function, how the memory is allocated, similar to the single linked list. How we have allocated the memory? By using the malloc, right? See, struct node pointer new node, similar to the single linked list. There is no variation here. Struct node pointer, first one you need to say about the type definition. That is, our type definition is struct node pointer. After that, how much memory must be allocated? Malloc. How much memory must be allocated? Size of that particular struct node. After that, I need to enter the data. With this one, what happened here? A node is created, and here the left one is this one and the right one will be here, and this is a data session. This is the element with the 100 malloc. Whenever you use that malloc, some memory is created for this particular node. After this one, enter the data. Scanf. See here, instead of that taking a or a b variable, directly we are saying that in this new node, at this particular data, ampersand of new node data. New node data. This is a new node, right? The name we have given is new node. In this new node, in this particular block, in this particular section, in this particular block, in this particular section, I need to enter some data. For example, here, by using the scanf, if I read the 10, that value will be inserted at this place. After that, new node left equal to null. Initially, this will be marked as a null. And the new node right equal to null. Here also, it is marked as a null. Return new node. Once a memory is created, it will write the true. This is about how we are going to create a node in a double linked list. The first one is you need to define the struct node with the 2 pointers and 1 integer type. After that, we are going to call the function getNode function. By using the malloc, we are going to allocate the memory. After that, the left pointer will be marked as a null. In the new node, the left one is marked as a null. In the new node, the right one is marked as a null. After that, the data is inserted by using the scanf statement. In this way, we are going to create a node. Now, we are going to see the different operations that can be performed in a double linked list. That is, inserting a node at the beginning. At the beginning, we are going to start pointer as a null. Why? Because till now I haven't operated anything. So, initially what happens? We are going to mark the head pointer as a null. Once if the head is null, if head equal to null, once if the head is null, what I have to do? If head equal to null, first I need to create a node by calling the function create a node function or the get node function. We are going to get the data. We are going to have this node. Previous one, it is also called as the left one, and this will be treated as the right one, and here we can insert the data. This is a new node with some random address 100. Initially, the head pointer is going to have the address null, and after that I have created the new node with the left link, data, and the right link. Now what I have to do, where I need to insert? My task is I need to insert a node at the beginning. For this one, what I required here means this will be the first node, yes or no? In a double linked list, how can I say that this is the first element? If the left link is going to have the null address, then we are going to say that this is the first element as per the double linked list. The first element, left link, is going to have the null address, and the last element, right link, is going to have the null address, isn't it? So here also we are going to do the same thing. New node, memory is created, memory is allocated, left, data, and the right. So what happens? How can I do that one? Means by writing new node, the previous one, the new node previous one is going to have the address null. Done. After that, head equal to new node. If you observe that, here also it will be marked as the null. Why? Because this will be the first node and this will be the last node. This will be the first node and this will be the last node. Already at the time of creating a node itself, we have decided that the left link and the right link is going to be marked as a null and the data value is inserted. Okay. If head equal to null, I made the left link equal to null. After that, this head should point to this node, that is 100. Initially it is null, but I should point this head address to this new node. How can I do that one? Means by saying that head equal to new node. Yeah. Now see, head equal to new node. We are going to point head equal to new node. If you add this one, if head equal to new node, initially it is head value is null. Now what I have to do? I should change this head node. I should connect this head node with the first new node element by writing head equal to new node. Here, inserting a node at the beginning also, I have the two cases. One is, till now I haven't inserted any element in a double linked list. So what happens here? The head node is going to have the null address, and the node is created with the left link null and the right link null, and the data is inserted. When can I say that this is the first element in a double linked list? Means if the left pointer is going to have the address null, then we are going to identify that this is the first element. So we are going to write the statement new node previous equal to null. After that, head equal to new node. This should point to the new node. Up to here, the first case is completed, which means that inserting a node at the beginning if the head equal to null. No, already I have some elements in a double linked list. Now I want to create a node. At the beginning, that is left one, data, and the right one. I need to insert this node at the beginning. If you observe this one, this is a general double linked list structure. That is, the start pointer is going to have the address of the first element, and the first element left link is going to have the address null, and the last element next pointer is going to have the address null. Now my case is I need to insert an element at the beginning. If you observe this one, new node next equal to head. Why? Because if you observe this one, this will be the first node in a double linked list. Yes or no? Yes. In a double linked list, the left pointer should be marked as a null. So here I should mark it as a null. That one should be marked as a null. And after that, some data inserted as a 30 or 40, anything you want. After that, this right link should point to the next one. This should point to the next one. This one. But where is this address? This address is present in the start. Yes or no? How can I write that one? Means by writing new node next equal to head. This is a new node, right? Yes. In this new node next, I should have the address of the starting one. This will be treated as the next previous, and this will be treated as the next in our coding. In this next part, I should have the address of this one, of the first element, previous first element. But where is the previous first element? It is there in the head pointer or in the start pointer. That's why we are writing new node next equal to head. In this next part, in this right section, I need to have the address of the first one. That is a 100. Should be returned here. Okay, done. Now see, new node, left link is pointed as a null. Data is inserted, and the right link is going to have the address of the first one, which means that now this one is pointing to this one. Yes or no? Done. Up to here, the task is completed. Next one is I should change this address. Yes or no? I should change this address to the previous one. If you observe this one, this is pointing to this one, right? And even this one should point to the new node. This one should point to the new node. How can I do that? First, read this value 100. 100, that is head previous. This is the previous one and this is the next one. This should point to the new node. How can I write that statement? Means by writing head previous equal to new node. Head previous. Initially, what is the head value here? 100. Move here. 100 previous should have the new node address like 900, 400, whatever the address it is at, must be returned here. That is a 900, which means that now this is going to point to this particular node. The task is completed. After that, what is the next rule? That the start pointer should point to the first element. How can I do that? By writing head equal to new node, which means that here I am going to change the address. Start equal to 900. Head equal to new node. That's it. The task is completed. So what we have done here, inserting a node at the beginning. Inserting a node at the beginning in a double linked list. Here we have the so many cases. What are the so many cases here? Means the first one, if the list is empty, if head equal to null. What is this head equal to null? Here inserting a node. Till now we have discussed, but let me revise this one again. Inserting a new node at the beginning in a double linked list, we have the different cases. That is, if the list is empty. If the list is empty means what we are going to write, how we are going to check if the list is empty or not. If head equal to null. If head equal to null, the list is empty. Now I want to insert a node at the beginning. So what happened? We have created a new node. This is the previous one or the left link or the next one or the right link, and this is the data. This is the data. Now after this one, what I have to do? I need to mark the previous one as a null and I need to mark the right one as a null. After that, the head should point to this new node. Yes or no? That's it. The case is closed. Why? Because this is the first node. In a double linked list, the first node and the last node of the right link is going to have the address. In this case, this is the first address and this is the last element. This is the first element and this is the last element. That's why we are going to mark the previous one and the next one as a null. After that, head equal to new node. Whatever the address you want to allocate. For example, if the address memory allocated for this one is 400, here also we are going to change it as a 400. The head value is changed as a 400. New node previous equal to null. Why? Because this is the first node, so we are going to mark it as a null. After that, head equal to new node. The head should point to the first element. This is the first case, it is closed. After that, no, already I have some elements, which means that this condition is not satisfied. Here this condition is not satisfied. Then what happens here? Already I have some elements in a linked list. Now, the next case, if the head is not equals to null, which means that I already have some elements. Now, our task is we need to insert an element at this place, that is the left link, right link and the data. It is also called as the previous one and this is called as the next one in our coding section. Now, what happens here? Insert data. Some data is inserted already. As this will be the first node in a double linked list, the left one should be marked as a null. The left one should be marked as a null. Yes or no? And after that, the right link should point to the first one. This will become the first and this will become the second one, right? This will become the first and this will become the second node. In a double linked list, it is a two-way list, which means that it is going to have the next element address and the next element is going to have the previous element address. Again, we need to check these addresses also. How can I check this one? This one should point to the second element, that is the previous first element. If you observe this one, where is the address of this particular node? It is there in the head pointer. It is there in the head pointer. So, I can directly write that in else part, if head is not equals to null, directly I can see that new node right equal to head. That is new node next equal to head, which means that some memory like 400, the new address is 400. 400 next should have the address of the 100. What is there in the 100? What is there in the head pointer? That is 100. So, here we are going to have the address as a 100, which means that this one is going to point to this particular address. The next one is, this should point to the first one. Yes or no? Every node is going to point to the previous element also. So, even this node should point to the first element. How can I write that? If a head not equals to null, if this is not the first element, if this is not the first element, I should change the previous address with the new node one, that is head previous equal to new node. Head means 100. 100 previous, this is the previous, this is the next. 100 previous equal to new node, that is a 400. Here it is changed as a 400. Done. Head equal to new node. Now, this should point to the first element. Yes or no? So, this one will be changed as a 400. Head equal to new node. Our task is completed. That is, inserting a node at the beginning is completed with this one. Now, we are going to see the coding also, like how we have seen the part wise, like we have performed only insert at the beginning function and we have called through the main program, right? Here also we are going to see the double linked list program by creating just starting with the inserting a node at the beginning function. We are going to see in a similar way.
Yes, now we are going to start our double linked list program. All the three header files are included, which are necessary for our program. The next one is, here we are going to declare our struct node. In our double linked list also we require the node. In our node, in a double linked list, it consists of the three elements. What is the first one is the struct node pointer previous, which is going to point to the predecessor node. And the second one is data, that is of the integer data type. And the third one is the data type of the next one, which is going to point to the successor one. Yes. With this one, we have declared our variable, our node as a global variable. And for that one again, in every double linked list, it consists of the header pointer, which is going to point the address of the first element. But initially, the header pointer will have the value null. That's what we have declared till now. So what we have declared in a double linked list, every node consists of the three parts. That is the previous pointer, data, and the next pointer. Previous pointer is point to the previous element, that is the predecessor node. The next pointer is going to point to the next element where the successor node is there. These are the global variables we have declared. The next, our task is we need to perform the insertion at the begin function, right? So before you write the main program, first we need to define our program. So right now, void insert at begin function, and we need to get the value from the main program. So here we are going to declare int data, and after that, done. In this int begin, first of all, I need to allocate, I need an memory, right? For that purpose, first allocate the memory by writing the statement struct node pointer new node, how we have written in our single linked list. The same line must be returned here. That is a struct node pointer. And after that, by using the malloc, we are going to declare the memory. How much size? With the size of our struct node. Yes, with this line, the memory will be allocated for our new node. Yes, after this one, new node data. In this new node, data value I need to insert. That will be same as that of the whatever the value we got from the main program. And after that, as this is the first node, this will be our first node, right? So what happens here? The new node previous will be marked as a null. Why? Because in the double linked list, the first node previous element is going to be marked as a null. That's what we have returned here. Yes. After this one, the new node next will be same as that of the head. Like if the header pointer is having the null means that will be the first and last one. So even there it will be going to mark as a null only. Or else we are going to mark it as a head. If head not equals to null. If head not equals to null, which means that already some elements are there. If already some elements are there means the first element, the initial first element previous must be pointing to this new node, right? So here I'm going to write head. We are going to change the head previous element should be pointing to the new node. So head previous equal to new node. And after this one, we are going to change the address head equal to new node. Whatever the memory we have allocated, we are changing into the this one. Yes, with this one, the task is completed. So even let us write the code printf. The node is inserted successfully. Inserted. Done. Yes, this is our insertion at the begin function. Now what I have to write, I should continue with my main program. I need to call this function from the main program, right? So start with the void main program. And here, this should be similar to our single linked list. That is first, let me declare int data. This is a common variable we require right now. And let me write in the statement while of 1. Why? Because this must be rotated. So let me write in the while statement itself. After this one, let me go with the option. It should display that printf in order to display the values 1 to insert at begin. To insert at begin function printf to display the values. If it is successfully inserted or not, how can I see that one? Only through the display function, right? So let me add it here to display. To display, I need to choose the option 2 and printf 0 to exit. Exit. Let me write the slash n. Yes, it should ask for the choice, right? So again, let me print the statement. Enter your choice. Among these three, which one you want to choose it? Enter your choice. Slash n. Scanf. Comma. Ampersand of choice. So here we require one more variable, that is a choice variable. So add it here. Done. Yes. Switch. Choice. Here. Let me enter this one. For first case, I need to call the statement insert at the beginning, right? For that purpose, again, I need to enter some data. So let me ask the question to enter the data. Enter the data. Scanf, percentality, comma, ampersand of data. All these points we have written even on our single linked list. Now, everything is common for the main program. Insert at begin, and I need to send this data as an argument. Done. And after this one, we are going to add the statement break. Done. Next one is case 2 for the display, right? So again, I need to call the function display function. Display. And write the statement break. But we haven't included this break function, right? We are calling the break function, but we haven't declared that one. So come up and try to write that function also now. Void display, which is similar even in our single linked list, that is void display. What do we require here? We require one extra pointer, that is a struct node pointer temp. Why? Because I need to keep on traversing, right? So for that purpose, we require the temp, which will be same as that of the head pointer. Initially, both should point to the first element. That's what we are declaring. The temp pointer value will be the same as that of the head pointer. After that, I need to rotate the loop till while temp next not equals to null. While temp not equals to null, which means that I have some values in the temp. So what should happen? It should first print the data. Printf. It should print the data, right? So percentile D should print like this. And after that, user, comma, ampersand, no need of ampersand. It should be the of the data. So here we are printing the temp data. After that, I should move forward, right? For that purpose, we need to write the logic temp equal to temp next. Yes. After completion of this one, it should give the space print slash n. This will help you to come to the new line. Done. This is about the display function. So here we have completed case 1, case 2 and case 0 for the return. I need to come out. So directly I am going to write the return statement. Done. Yes. Now save your code by pressing F2. Now compile your code. 5 errors. Case missing semicolon. One should learn even these errors. How to solve these errors also you should learn. One error, that is a slash n. It is a printf statement, right? Done. Now save the code again. Now again compile the code. Okay. Control F9. Yes. If you observe that we are having the so many things, right? Let me clear this one again. In your main program, after this one, just write down, after declaring a variable, just write down, clear the screen. Save the code. Control F9. Yes. Now to insert at the begin, to display and to exit. First I need to display insert, right? Let me choose the option, enter your choice. Enter the data. 54. The node is inserted. Again, let me choose the same option, insert at the begin. Let me go with the option 10. Now let me go with the option 2. If you observe, 10, 54. Both are printed, right? Done. So insertion at the begin is completed till now in a double linked list. Now press 0 to exit.